In this video, we're going to be looking at how to calculate the mole from a volume of gas at STP. When doing any calculations in chemistry, all volumes must be in litres. This includes when calculating volumes from solution and volumes of gases. So if you were given a question that said you had 20 ml of hydrogen gas, you would need to automatically convert it to litres, so it would be 0.02 litres of hydrogen gas. Now, pressure is a measure of force per unit area. Now, this helps explain to us why we shouldn't be wearing our high heels on the lawn. You apply a force onto the ground, but the area that it's being applied through is very, very small, which is why the pressure is high and you sink into the lawn. Whereas when you are wearing your hiking boots, you're applying the same force but over a much larger area, and as a consequence you don't sink into the lawn. Now, pressure is measured in newtons, which we remember from year 10. Area is in meters squared, so the unit for pressure is Newton meters to the -2. Now this SI unit corresponds to another SI unit which is called the Pascal. And in chemistry we will be using kilopascals. And remember, a kilopascal would represent 1,000 pascals. You may have heard of hectopascals on the news when they're talking about the weather. So 101.3 kilopascals is equal to 1,013 hectopascals. Now, there are, of course, other units of pressure. These include atmospheres, millimeters of mercury, and bar. Now, to give you an example, you can actually interchange between all of them. 1 atmosphere is equal to 760 millimeters of mercury, which equals 101.3 kilopascals, and which equals 1.013 bar. In our study of chemistry, we will only be using kilopascals. In chemistry, we will be using temperature, and remember, temperature is a measure of average kinetic energy. Now, when we measure the average kinetic energy in everyday life, we tend to use the Celsius temperature scale, which is based on the boiling and freezing points of water at normal atmospheric pressure. Other temperature scales that you may be familiar with are the Fahrenheit scale. For our chemistry, we need to use the Kelvin temperature scale or the absolute temperature scale. And so we need to be able to convert between Celsius and Kelvin. Now, to do this, to convert between Celsius and Kelvin, you add 273.15. Now, you don't have to remember that. That's on your data sheet. So let's try an example. Say I had a temperature of 25 degrees Celsius. So if I want to know the temperature in Kelvin, I'd go temperature is equal to 25, add 273.15. So the Kelvin scale is 298.15. And we just write Kelvin. We don't write the degree symbol. So this leads us to Avogadro's hypothesis. Now, Avogadro said that if we have equal volumes of gases measured at the same temperature and pressure, they will contain equal number of particles. Now this only applies for gases. Gases only. Not for solids and not for liquids. It only works for gases. And to explain why, we need to go back to the kinetic theory. Now, if you think about the kinetic theory, it says that the average distance between the molecules of a gas is extremely large compared to the actual size of the gas molecules. So in this container, here is a gas and here is a gas. Now, the sizes of these two gases is very, very small compared to the distance between them. So this means that for any gas sample with the same number of particles, it will occupy the same volume at the same temperature and pressure. So if we had 1 mole of hydrogen gas at 0 degrees Celsius and 100 kilopascals, it would occupy 22.71 litres. If we took 1 mole of helium gas at the same temperature and pressure of 0 degrees Celsius and 100 kilopascals, it too would occupy 22.71 litres. And similarly, if I took 1 mole of nitrogen gas at 0 degrees Celsius and 100 kilopascals, it would also occupy 22.71 litres. So, in order to calculate a mole of volume at STP, we need to know what STP means. And STP is simply standard temperature and pressure. So according to IUPAC, the International Union of Pure and Applied Chemistry, the standard temperature is 0 degrees Celsius, which is equal to 273.15 Kelvin. And the standard pressure is 100 kilopascals. And any mole of any gas at STP will occupy 22.71 litres. Now, because we know that 1 mole of any gas at STP occupies 22.71 litres, we can create a formula. So this formula states that the number of moles is equal to the volume of the gas in litres divided by the standard volume of 1 mole of gas, which is 22.71. Now this formula can be found on your data sheet. Now let's try an example. We've been asked to calculate the number of moles of 2.54 litres of hydrogen gas at STP. So once, like any stoichiometry, I'm going to tell my marker exactly what I'm doing. I'm going to find the number of moles of hydrogen gas is equal to V over 22.71. Now I substitute my values. I've got 2.54 litres over 22.71. Stick these values into my calculator and I find I've got 0.112 litres. Remember to check significant figures. There are 1, 2, 3 significant figures, 1, 2, 3 significant figures. Now let's try another example. We're going to calculate the volume of 2.5 litres of ammonia gas at STP. So using our formula, number of moles of ammonia is equal to V over 22.71. The number of moles is 2.5. We don't know the volume, but it's in 22.71. Now I'm going to need to rearrange my formula. So the volume will equal 2.5 times 22.71, which is equal to 56.8 litres. Remembering to check our significant figures. There are 1, 2, 3 significant figures, 1, 2, 3 significant figures. Now I'd like you to try some yourself. So go to the OneNote, Kinetic Theory, Calculations, Gases and the Mole. There are some examples right at the bottom of the page. Now if you want to check your answers, go to the space section on the Kinetic Theory and I'll have some YouTube videos on those answers.